Hello and welcome back. In this section, section 4.3, we're going to be looking at various properties of logarithms that are based on some properties of exponents that we saw a long time ago. So the exponential product rule that we saw in, I believe it was even the prerequisites chapter, when we multiply two numbers that have exponents, so b to the m times b to the n, we end up adding the exponents. And exponential functions and logarithmic functions are inverses of one another, so we expect something very, very similar to pop out of logarithms. So what ends up happening is if we take the logarithm of two numbers that are being multiplied together, kind of like up here, we end up adding the logarithms, kind of like here. So the pattern still stays roughly the same. We can turn multiplication into addition using logarithms. So the log base b of m times n is log base b of m plus log base b of n. I forgot the b there. So let's do a couple of examples. This isn't meant to be very difficult. Log base 6 of 7 times 11 is just going to be log base 6 of 7 plus the log base 6 of 11. And that's it. Let's go through a slightly longer example. So here I have log without a base written down. This means that this is the common logarithm, as in the base here is meant to be 10, but we just haven't written it down. So this is log base 10 of 100 times x, and we can write this as the common log of 100 plus the common log of x. And one thing I do want to point out here is that we can simplify this further. So we're thinking about, so the common log is log base 10, and 100 is in fact just 10 squared. So when we look at the log base 10 of 10 squared, this is asking what number do you have to raise 10 to get 10 squared? Well, that's just the number 2. Again, to reiterate this, log base b of x is equal to y just means b raised to the y power is equal to x. So this is 10 raised to what power is 10 squared? Well, it's 10 raised to the second power is 10 squared. So this is where the 2 comes from. So this is as simplified as I can make this. This is as expanded as I can take the log of 100 x. Now, from before, we also had when instead of multiplying, if we divide exponents, we end up subtracting up top. So b to the m divided by b to the n is b to the m minus n. Okay? And the same thing roughly happens with logs. If we take the log of two numbers that are being divided, we end up subtracting them as logs. So the log base b of m divided by n is going to be log base b of m minus the log base b of n. So let's go through a couple of examples. So we can look at the log base 8 of 23 divided by x. Well, we can turn division into subtraction. So this is going to be the log base 8 of 23 minus the log base 8 of x. And this is as simple as you can make it. This will be some number, but it's going to be some horrible decimal. The next one, we have ln. And ln is the natural log. So this is going to be the log base e, and is the same as what we can see up here. So again, we can use our quotient rule to say that this is going to be the natural log of e to the 5th power minus the natural log of 11. And the natural log of e to the 5th power, again, this is the natural log, this is the log base e of e to the 5th power. and this is just going to be 5. So this is 5 minus the natural log of 11. Again, the natural log of e to the 5th power is just the same thing as the log base e of e to the 5th power. And exponentials and logarithms cancel out when we have the same base here. So we have the same base, so this is just going to be 5. So we've seen the quotient rule and the product rule for exponentials, but we also had the power rule. If I take an exponent, an exponential, and I raise it to another power, it's as if I'm multiplying. And the same thing happens with logarithms. If I take the log base b of m to the p power, it's as if I'm multiplying, and I take the p out, and I write p times the log base b of m. And I think this is maybe the hardest one to see why this is true, but I think it's also one of the nicest. So here we have the natural log of x squared. And essentially what we can do is we can take what's in the exponent and move it out front. So when I take this p and I move it out front, I'm just going to get 2 times the natural log of x. So this is all there really is to it. We're taking the exponent and we're turning it into multiplication. Kind of like up here where we have b to the m, all this raised to the nth power, turns into multiplication, m times n. When we have log base b of m to the pth power, it's going to be p times our log. So let's use this in the following. So let's expand these guys here. So I have log base 6 of 3 to the 9th power. Ooh, I've got a power. I can pull that down out front, and this is going to be 9 times log base 6 of 3. Cool. This next one, I want to simplify this a little bit because this doesn't look like anything raised to a power. But the cube root of x is the same thing as x to the 1/3 power. And now I go, aha, I have a power, I have an exponent, which I can then bring out front. So this is going to be 1/3 times the natural log of x. And then this last one, we've got the log of x plus 4 all squared. Well, I have an exponent here, so I can pull that out front, and this is going to be 2 times the log of x plus 4. Note that I don't have a base, which means that the base is 10. And here I have log of x plus 4. And what I'm about to write down is very incorrect, and I don't want you to make this mistake. So I will make this mistake and show you what happened. Sometimes it's really tempting to go, oh, if I'm adding, I can pull that apart into log of x plus log of 4. This is absolutely incorrect. The way that what we can turn into addition is multiplication. So if this was log of x times 4, I could pull that apart into addition. But anything being added together in the logarithm can't be pulled apart. So we won't look at this anymore because it's incorrect. So the log of x plus 4, this can't be expanded anymore. So all we can do is write 2 times log of x plus 4. So we have those 3 rules. We have the product rule, where we can turn multiplication into addition. We have the quotient rule, where we can turn division into subtraction. And we have the power rule, where we can turn exponentials into multiplication. So let's use all 3 to expand a couple of these guys. So here I've got log base b of x to the 4th times the cube root of 9. So the first thing I'll do is I'll say, oh, we're multiplying a couple of things. We can turn multiplication into addition. So this is going to be the same as log base b of x to the 4th plus log base b of the cube root of y. One thing to notice is that the base of the logarithm never changes. When we apply the product rule, the bases are the same. When we apply the quotient rule, when we apply the power rule, the bases stay the same. So let's see if we can simplify this a little bit more. Well, here I have a power, so I can turn exponents into products. So I can pull this down and I can write 4 times the log base b of x. And then over here I have the cube root of y. Just like before, I can recognize that the cube root of y is just y to the 1/3 power. So I've just replaced this with an alternative way of writing it. And we can see that this is going to be the same as the other half of this equation, where I have an exponent. So I'm going to bring that down out front and write 1/3 times the log base b of y. So we've expanded this out as much as we can. I can't simplify log base b of x and log base b of y anymore. So let's look at one more of these guys. Log base 5 of the square root of x divided by 25y cubed. So let's just apply our rules one at a time. For instance, we're dividing numbers here. So we will subtract the logarithms. And then here we can see, okay, we're multiplying 25 and y cubed. So let's expand that guy as well. So this is going to be minus, and I want big parentheses here, log base 5, log base 5 of 25, plus log base 5 of y cubed. Cool. And I'm subtracting everything here, so let me distribute the negative sign. So minus log base 5 of 25 plus log base 5 of y cubed. Oops, I didn't distribute my negative sign. There we go. So let's simplify some things. The first one, the square root of x, this is going to be the same thing as x to the 1/2 power. This next one here, log base 5 of 25, 5 squared is 25, so this is going to be 2. Again, the log base 5 of 25 is asking 5 to what power is 25? Well, 5 to the 2nd power is 25, so this is going to be 2. And then lastly over here, we're going to subtract log base 5 of y cubed. But here I have an exponent, so I can bring that guy out front to say I have 3 times log base 5 of y. And then the only thing left here is I have another exponent out front, so this is going to be 1/2 times log base 5 of x. I can bring that exponent down. Minus 2 minus 3 log base 5 of y. I can't simplify log base 5 of y, log base 5 of 2, and this is our final answer. This is as expanded as we can make this. In the next video, we'll start looking at how to take something like this and combining it into one logarithm.